Wow, I assume everybody's awake after that video and that great speech by Peter. So, all right, there it is. So I wanted to say, I think I should have said welcome New York and welcome data enthusiasts here. It's a great, exciting time for Capital One, the way the journey is in terms of how we are leveraging technology, how we are leveraging open source, and what we're able to do within the organization. Most of you probably know Capital One from the TV ads with obviously the venture card with Samuel Jackson, I think Quicksilver as well these days, Jennifer Garner coming up, the Visigoths. But we're also one of the largest digital banks in the US, right? So we do a lot of this capabilities was built on the core foundations of what was information-based strategy, which was the core to Capital One, which is all about data about 25 years ago, right? So it has been the bread and butter for Capital One about data being the key drivers for our growth and strategy around how do we enable ourselves and minimize some of the challenges out in the marketplace. We are also the fourth largest credit card issuer. I'm sure that's not by any surprise because we probably have cards everywhere in the US, and most probably again it's one of the largest issuer in the all kinds of walks of life, right? So focus for today's discussion, like the introduction, was real-time cyber technologies. So what I'm looking to share with you here is really about the frameworks, the motivation, the vision, and kind of the roadmap which we thought about when we took on the whole opportunity around cyber, which was pretty new for me, at least when I started it. And it probably is a very vast area given the recent cyber threats which you see in the marketplace. I'll provide you a brief architectural overview or machine learning use cases, but I want to hone in on a couple of things, which is the primary objective of my talk here is really the automation of all of this to make things real, right? So how do we make most of this applicability on when we talk about building machine learning, building models, building these capabilities, how do we actually take this into production and put it into the hands of our end users and make this whole real, right? So that's part of some of the things which I want to share today is whole aspect of how do we automate the whole pipeline, including machine learning. So the news about Target, the recent news about Shift attacks, I'm sure there are plenty of bad actors out in the marketplace who are trying to come and steal information, especially with the financial industries like us. There are plenty of tools out there in marketplace as well which monitors, and especially in most of these attacks, you'll find if you go back and dig deeper that these alerts were notified to people, and because there were a billion events, it's very hard to find the needle in a haystack, right? So the problem is really about how do we enable using machine learning to identify the events, which is very critical, and take relevant actions against it, rather than doing post-mortem analysis on how these alerts or where did it come from. So that was part of the challenge which was thrown to us is really hone in on using the log data, using the machine data, how do we start building analytical frameworks around these models, which we can not throw out thousands of events, which becomes humongous for people to consume, but really hone in on the key details of what these attacks are so people can take action around it. So these are some of the primary focus which on sample use cases we have on security, and the second action of it is technology, right? So these two are almost in parallel. If you look at the data itself, both of them use the log data. The security is focusing on finding the bad actors, either through information leakage, through software coming in, malware coming in, and whatnot. And the technology operation is really self-healing infrastructure. How do we build enough intelligence within our infrastructure? We just talked about IoT, and how do we understand each one of these devices, and how do we make sure our technology operations teams is using the same data with the same capabilities, and have a unified single pane of glass view of all devices attached to it so they can hone in on a problem statement when it happens. So we found synergies between the two use cases, and we started applying those synergies as we build these platforms. This is a high-level conceptual view of the architecture itself. The most important aspect is you'll see the real-time aspect and also the machine learning piece attached to this. When you look at this particular pictures, you have obviously data coming in, which needs to get enriched. Enrichment could be based on it could be geolocation enrichment, which are probably the low-hanging fruits. And there could be a lot of intelligence which you go out to the marketplace and get data, and you enrich the data because ultimately you want to find patterns within these behaviors. And as you get this data, we do have ability to find anomalies both through machine learning and through rules engine to send dynamic alerts to people on what's coming in and what they should be looking for. But at the same time, we're also able to apply machine learning on the wire as we build the training data sets and real-time modeling and deploy those real-time modeling into production. And this is a continuous loop feedback which we have built up using technologies, including H2O, but also including some of the big data technologies with Apache Metron as a reference architecture. So one of the key things we did with the machine learning piece is around the model as a service concept, right? So how do we start deploying this model as a service so you could actually make this very, very consumable in an automated fashion. So what was the core when we started this? This was about 9 months ago when we started looking at how do we facilitate innovation and transformation within the organization. So we wanted to take few steps about it's talked about quite extensively across the board, right? So faster prototyping. We talk about bridging the gap between prototypes and production. How you build an open collaborative environment. And transform all of these equations. So there has been a lot of discussions around that, and one of the things which I really enjoyed from working with some of the H2O leaders was understanding that you need a domain scientist, you need a data scientist, you need a software engineer, you have a DevOps practice as a collective group of people working together to solve some of these fast prototyping aspects. It's not done in silos. It's really breaking down the silos and bringing teams together who can participate in all of these equations and make the culture of fast prototyping real. The next big thing is how do we take this faster prototyping into production, right? So if you're not able to take this into production in a meaningful way, where you can get real feedback from your end users, it is just a prototype, right? So it's really good. You can have a lot of talks about it, but ultimately the cherry on the top is really having the system in production. And that's part of what we established right from the get-go, that's our objective, right? So we want to be in production. We want to use these components in production in a meaningful way that our users can provide feedback to us, and we can work on it. And we are definitely there, and that's been our mojo. The open collaboration piece is all about, we are an open source community here, so we talk about the open source way of doing things. It's really allowing people to contribute their ideas, contribute across the organization. Within and outside the organization, Capital One has now started to publish some of their tools and techniques to open source market. I think the Hygia, which is the DevOps pipeline, which is very popular out there in the marketplace now. So we are embracing that culture internally as well as we bring these teams. It's a huge transformation, especially in the cyberspace, to get there, because what we learned is we will have to build tools and frameworks to support the open source community internally, because there's no one single answer which solves all the problems. The biggest one would be governance and security, right? So how do you, and I can keep talking about security aspect all day long, but how do you solve for those? And we understand that we will have to build these products with network effects to allow people to contribute for that particular problem they're trying to solve for and make it real, right? So if a group of people wants to bring data and want to work on the data, how do we allow the collaboration to happen within our environment to take it to production, right? So then, and take this all the way through. So the way, just exploring the machine learning aspect of it, so obviously we have both supervised learning, unsupervised learning. Our techniques or supervised learning is probably best ways to start with machine learning. The one thing which I'll touch on is the feature engineering piece, which is always intriguing to me, right? So I come from the data engineering background, and when I talk to most of the data scientists, obviously the feature engineering is done through either scikit-py or whatever tools is available that seems to be tool of choice along with the data. So the data needs to be production data, so we need to have sandboxes. And we need to have these tools available for you to continuously learn and really engineering the elements of bringing this together on how do we automate feature engineering. There is a reason behind that. The feature engineering, when people are working on it, will take you so far. As we progress into the AI world, the automated machine learning and automated feature engineering is going to get real. And how do we best position for that is part of the problem statement we are trying to solve. And that's where we will start leveraging H2O's capabilities, some of the H2O capabilities. The other big thing is I think we are moving away from a single model to ensemble of models, right? So it's not one model which is going to give an answer. It's a collective model which is going to provide you that kind of vision. Again, how do you build frameworks and capabilities around ensuring that ensemble of models is built and productionalized in a meaningful way? This is probably very, very familiar, that model building is very iterative in nature, and it has got high touch points between these iterative processes that you want to jump around and you want to run through this. And it also goes to the aspect of governance, right? So if you understand for each one of your organization what is the iterative process of model building, then you could put some level of governance around it to make sure that the regulatory compliance issues are satisfied, especially in the financial industry. It's an extremely important that we satisfy regulatory policies around models and the model performance. The pipeline kind of helps us to understand what are the touch points and where do we need to automate some of these features and capabilities. So I came up with this 5 core principles from an engineering aspect on how do we go about it. First one is obviously it's got to be easy to use, and this is probably the most important one in my head. That if you don't make it easy to use, you're going to get a lot of resistance from people to change. The change aspect is they're all pretty familiar with a lot of tools, right? So if you don't make this platform as easy to use as other platforms, it's going to face some resistance. It's got to be efficient, right? So we talk about performance, we talk about scalability. It has to have the flavor of like rework needs to be minimized. And one of the things which is important is, like I talked about feature engineering, which is where I believe there are a lot of opportunities exist, is to make that highly efficient. The third one is scalable, right? So this is the world when now we are talking about AWS, the cloud, or we talk about horizontal scaling of these capabilities and really going into parallel mode, which, again, from a platform perspective, that's very, very important. Being platform agnostic. So there are multiple machine learning tools available in the market, and it's easy to throw a REST API on top of it and then integrate that using a REST API. But making it deployable in multiple platforms is also one of the key things which I embraced as being important as we've made our choices on the tools. Of course, well-governed, right? So we need to protect our IP. There is no questions about it. And we want to make sure that whatever tool we pick, we can stand behind it as well. So this is where we started leveraging H2O. I got introduced to H2O about 8 months ago in Strata conference, and I started enjoying a lot of things which H2O has put in place. But the mission which we really started with is augmenting our human judgment by harnessing machine learning, right? So I believe we are at that phase where we are still leveraging a lot of human judgment, but we can harness this machine learning capabilities to put that together. And the objectives is to implement established best practices for data scientists and general purpose programming languages. Like it's a programming language of choice, fit for purpose. Like whatever you like, you should be able to use, but you should make it general purpose. Automation, right? So end-to-end automation of a model, build generating of risk management, regulatory artifacts, which goes back to the governance piece, right? So how do we make sure that you share the model performance with your governance offices and reduce the iteration timeframes on how you build the models. And portability, right? So you should be able to port this model from where you build it to multiple application points. So in our case, we have it running in a batch cluster. We also have it run it on a real-time cluster. So we run it on Storm and Spark. Spark is where we do all our batch learning, and Storm is where we do our real-time learning. So that's the portability piece, to make sure that the models you build, it can be easily portable and deployed across multiple apps assets. So the how part, I think I just covered it. We work very closely with our model risk office. We built, again, using H2O, complex data processing workflows. This is where Stream comes into play on some of the SIEM capabilities, make this doable, and like the model advisor piece, which I keep talking about with the H2O folks, is very, very key, critical part of the governance piece for the automation to make all of that real, because it's got the artifacts around all the model statistics, right? How did the model perform with what data, and what is the deviations and all the good stuff, right? So it's very, very, very important that we use automation around that. The API focused, like I said, there is multiple ways to look at the API. At least in our case, we looked at the portability in the sense that we are able to deploy this model into multiple execution engines or multiple compute engines, right? So tool of choice. So we have a cluster which runs pure H2O. We have a cluster which runs sparkling water. We have a cluster which runs H2O inside inside Storm. And the idea is to basically, depending on the data which goes in, you're able to predict the models or predict the behaviors of that data, but also have a traceability attached to that. So this is the piece where how we look at, and I'll probably hone in on the feature pipeline a little bit. The data pipeline and data munging is probably very, very common, right? So everybody needs to do that. Today, the data pipeline, data munging, there are multiple ETL tools available. You have multiple ingestion tools available to you to do this work. So what we try to do with Untitled Chapter 1 is to give a homogeneous platform that you don't have to jump around in many different places. And we are trying, like I said, we try to build tools and frameworks around these open source technologies to make the ease of use real. So that was one of the first core principles which personally I have established for myself to go after these as I enable this within Chapter 1, right? So we do know that there are multiple tools available, but based on the popularity, we try to get this together. The feature pipeline is the interesting thing because the way the features are selected, the way features are automated, I think it's a science in itself. It's got a lot of interesting nuances on who is building the features, how they're building the features, and how do they apply the features in the model building. Again, if you ask me, I will say it's just that's where most of the iteration happens, right? So people spend a lot of time on these features. It's easy when we do 10 to 15 features, but as the features goes into the hundreds, and if you take it into the deep learning space, it's numerous trees and whatnot. The fact that needs to be automated and that needs to make sure that it goes to the proper governance structure was one of the things which we're trying to work through Stream, in terms of that we will have a feature extracted, whatever language you choose, for both training and in the real-time model, and then use that as a data set rather than a code, right? So use the features as a data set. That's something which we are working on. And I think that comes in the next two slides. But I just want to give a component architecture of the pipeline itself. So the way we sourced all of this is we use, obviously, S3 as the data store. And because H2 is all in memory, it makes it very, very easy to build this pipeline in memory and make schema on read, right? So we bring the schema, what data we need into memory, and just munch on that data and extract that features. And we store the features back into the storage area along with the data. So when we have to deploy these models, we can actually take the features along with the model code and deploy it to the different components and make it much more automated. So this is where it kind of shows that piece. If you look at the feed.ex.py, which is all the features, which is now available in the large batch area, the incremental batch area, and the Storm area, right? So now it works on the raw data sets, incremental batch, and a large batch, where you do all the trainings. is done in the large batch, and then you do incremental batch where you have to do the alert-like use cases and real time where you're really figuring out if there are anomalies coming into play, and it's all driven through a single interface, making it easy for use for people with good DevOps practices. This is another view of that same architecture where you see the H2O kind of gives you the capabilities of, again, with sparkling water, you can do both save data stores, you could do the Lambda architecture with that, you could bring in live data streams, but you can also apply a lot of H2O capabilities, like data munging is one of the capabilities if you're bringing the data into memory, large volumes of data, where H2O key value pair, like non-blocking hash tables is really, really interesting opportunities for us. Right? We have been experimenting with the non-blocking hash tables to create the data tables within H2O to run some of these queries. So again, bringing all this together, the automate relentlessly is a key piece, right? So we want to make sure it's testable, it's not, make sure that it's robust, and allows for creativity. The next big one is the reproduction, right? So we don't want to just build it and throw it away and show the metrics. We want to make sure that it goes into production and we can strive for that repeatability within our environments. Again, being open, again, coming to the culture which I just talked about, that's the culture we are embracing, that we want to allow creativity, we need to be outside our comfort zone, and we need to be open to many ideas and understand the values others brings to the table and really create that network effect, right? So we want to really bring that within the Capital One culture so that we can bring all of this to bear. The technical leadership is again, a key part of that. If we don't demonstrate that, I think it's very important for the teams to see what we value, and they can also embrace some of these cultural aspects which I just talked about. And again, this is definitely something which is showing some very, very good behaviors within Capital One and what the results we are seeing with that. So one of the things with automation, like I said at the earlier of these, I'm going to focus on getting into production, right? So that's the real aspect of it, right? So we are not necessarily focused on building the models just for sake of building the models or proving an anomaly or whatnot. We want to run it in real systems. And that's where the automation actually very, very helpful, right? So it allows the best practices of risk and modeling. It gives you the building blocks, works towards interfaces and building blocks of APIs. It makes the relentless pursuit of taking to excellence real, right? So we do want to make sure that, again, like I said, it's really the proper building blocks and what you can build up to production. You should be able to throw things out, no question. I think it's without saying, right? Things will fail, but this gives you an opportunity to experiment a little and pick the right tools and right technologies to take it to production. The last line is very, very important. The analysis is in code, so it's reproducible, it's testable, under version control. The testable piece, which goes back to the training, there is always a saying, I think I've heard it many times, the training model gave me the results, but production it's got different results. What do we do about it? So part of all of this is to make that window really, really minimized, right? So you should be testing against the same data based on the previous slide I showed you guys. Before, if you're using the same features in the large batch, in the incremental batch, and in the real time, that gap should be really minimum, right? So your training data set and production data set should be almost the same. So hopefully that we will see the results for that. So obviously, open source is setting the pace. We are here in the open source conference. We use a lot of open source tools and technologies. It gives us a lot of flexibility in what we want to achieve. But at the same time, it also allows us to be very, very creative on what frameworks we need to build and how do we augment the open source technologies to make it really run effectively in production. Open source it's got its pros and cons. I don't want to go into what pros and cons are, but it is something which has freed us quite a bit to be outside of our comfort zone and really experiment with a lot of stuff which we can do and bring these technologies to bear. If you want to go that route, talent is very, very key and essential, right? So you want to build the right engineering teams who has the mindset to experiment. You have the mindset to fail fast and make choices that will work, that will not work, and be ready to live with those choices. Going back to the conference, predictive analytics is the key. So everything starts with the aspects of your learning all the time, and you're analyzing the data points which you got. I think that's what I have. So happy to take any questions you have. All right, there's a question there. Oh, sorry. Almost.
The question is, how often do you retrain the models? And what is there a rule for knowing how often you would retrain models?
Great question. So the how often is, I think we want to rephrase that as like, we should be retraining the model almost every day, depending on what data is coming in, if you automate it the way which we're talking about here. And if you find any anomalies, I think it's you should look at it from that perspective. That what do I need to do to get my model to perform much better, depending on new data points coming in, right? So the model is self-learning. That's the journey which we want to get to. That if you automate the whole aspect with the incremental batch, the large batch, and the real time, then you have a lot of heuristics through your model governance practices that you can go back and look at what you need to do to retrain the model based on the new information which comes in. But I believe it needs to be continuous and automatic. All right, there's a question here.
Yeah, I have a question over here, sorry.
All right.
Yeah, so I just wondering how long it take your team to develop this open source project. And also, I also wondering, right now, Capital One is the open source is the only one, or you still have a hybrid approach, like you have open source and also you have a closed source platform?
How long will it take? For the project which I'm engaged in, it's about 9 months. We are in our 9th month on the cyber technology project, and it's not, by nowhere it's finished, right? So it's going to continue, but we are at a stage where we can talk about a lot of achievements we have got to. On the open source, closed source, I think open source does not solve for all the problems, right? So there is definitely aspects of software which makes certain things which is very valuable from a COTS product as well.
I think that was a nice sketch. So first of all,
sure.
Thank you for your presentation. Now I have 2 questions. I'll just take it back to back. The first one is like when I saw the security framework, there is a bit of an overlap with our software framework. So how is H2O differentiating on the specific security framework for artificial intelligence? And my next question is, how do you handle for a situation specifically for the banking sectors when you have machine versus machines? So for examples, the hackers can also make a behavioral analysis pattern. They can also generate a model, and they can also launch an attack because they knows it very, very well. Well, these are the similar check gates which you are going to block it across. So what are your security frameworks down the line for the future, for a machine versus machine? So that's my second question.
Okay. The first question was the framework looks. Yeah, so what we used is really definitely a reference architecture, as I said, from Metron, but we built on top of that, right? So Metron only takes it so much on the log analyzers and dynamic alerts, but the H2O piece was all integrated through our reference architecture. It is usable across any other patterns because ultimately it's what data you're sending in, what models you're building, and how do you make it repeatable. So if you put in the engineering effect for the other use cases, I'm sure you'll get to the same goals and same outcomes as where we are. On the second question on machine-to-machine piece to it, what I think the first belief is hackers will get into your shop no matter what you do, right? So if they cannot penetrate in, they'll find a resource like an intern to come join you and hack into your system. So there is the aspect of that. That's why it's a needle in a haystack, right? So it's always, there is going to be methods, there are going to be techniques they're going to find. What we are trying to do is make it really, really hard for them to do it. Right? It is really raising the bar on making it really, really hard for them to do it, right? So they have to spend much more cycles to penetrate into what we can do than making it easy for them, right? So that's the thought process around machine to machine, or how we are going to stop it, right? So yes, you can mimic a lot of things, but you can only mimic on the surface on what you see. You cannot really mimic on what you don't see underneath the covers. And if you make that really, really hard at every stage, I think that's where you'll see some benefits coming up. I'm almost out of time, so one question. Yeah. Okay. I'll get you next. So.
Hey, my question is about the kind of approach you have for, say, data preparation, like before the modeling actually happens. Like, I assume like it's basically like big data and like because it's like real time an application. So what kind of like exploratory analysis and like how do you actually like deal with trying to find things like collinearities and scaling and outliers, or basically like what's the approach to make sure that the data that's going into the model is actually in line with the assumptions of the model?
So great question, and it's probably a hypothetical answer, but the way we think about it is, if you're doing it in the large cluster, because that's where you store, right? So that's where your majority of the data is sitting in the batch cluster where you're training the model. You're training the model on the production data in the batch cluster, and if you want to transform the data, you will use the data munging, data pipeline capabilities to transform the data to what model needs. The biggest thing there is the feature extractions. What features are you going to put on that particular model before you build the model, right? So if you kind of isolate and box the feature extractions before you put it in the model, so each piece is scalable by itself. That's the thought process, right? And when you get to the model, then the whole aspect is a pipeline which gets. That's why it's a model pipeline, right? It's not a single event that you're doing that model by itself.
Do you work on like just like extracting some samples of data, or like how do you perform that? I guess like let's say like you have.
Scientists, I'll say that the feature pipeline, like that's why I said you could use Python language. People use scikit-py to do that, or you could use, like if you want to use some of the capabilities within H2O, you should be able to do that. I think we said like Pascal or Python, Scala, Java, whatever it is, you could use your tool of choice. But if you work within that framework of deploying those features within that framework, which goes into the model, then it becomes an interface conversation, right? So how you build the interface.
Okay. Thank you.
Features. Now you've got a question here.
I'm just wondering how you're using machine learning to make credit decisions. Maybe we can give an example.
Great question. I don't think I have the knowledge on the credit decisioning side of the house. So maybe I'll find out for you, but I don't know. Yes, sweet. Not a tough one.
What are the, top 5 frustrations, and what were the disasters that you thought you would not even hit when you started the project? How did you overcome them? What were difficulties in using, let's say, even H2O and open source, or in the bringing data into data lakes? So why don't you talk about
great question. What we are talking about is really something which we believe that is the architecture which is going to work, right? So when we put H2O, there are a lot of experimentation of H2O on Storm, or a lot of experimentation on Spark, or stuff like that. I'm sure there are production applications which is doing that as well, right? So when you start building a fully functional, we process terabytes of data today and hopefully grow that and larger aspects of it. When you bring so many different open source technologies together and deploy that as a single platform, the challenges are humongous, right? So that's where the relentless automation comes into play, that you want to do it. They're not built to interface well together. They're not built to work together. The simplest of simple things like Java version incompatibility, You'll face the simplest of simplest problems, which makes your life miserable. Again, that's where I think the aspect of keeping your changing components and stuff like that is very, very important in working through those challenges. So that's just on the component software side. On the data side, it's very similar, right? So you see a lot of marketing materials on interfacing with Kafka, interfacing with Elasticsearch, interfacing with X, Y, and Z. And reality is it's not so out of the box, right? So you do have to spend a lot of engineering time and making these components talk to each other. And that itself is a huge challenge, right? So then the next is the data format. So what is the right data format to do, especially if you're now presenting it to the end users? How do you want the end users? They're used to existing tools and applications, and you want them to start using new tools and application. That migration is never easy, right? You need to exceed expectations in the usability aspects of it. And that's another challenge which we focused on. Again, I can go back into a lot of these things, where every stage of the gate, we just focused on making it iterative. We learned, we built, we learned, we built, we learned, we built, and we are still in the same process. I don't think we are out of the gate yet. We are just early stages of our production rollouts right now, and we'll continuously learn and build towards the next generation of applications.
Please go, Bob.